Application caching is a technique used to store copies of data in a temporary storage location, or cache, so that future requests for that data can be served faster. This is crucial for improving the performance and scalability of applications. In the context of Azure solutions, caching can significantly reduce the load on databases and other back-end services, leading to faster response times and a better user experience. However, implementing caching requires careful consideration of various factors such as data sizing, connections, encryption, and expiration policies to ensure that the cache is both secure and optimized. Data sizing is a critical aspect of caching. It involves determining the appropriate size of the data to be cached. Storing too much data can lead to increased memory usage and potential performance degradation, while storing too little can result in frequent cache misses, negating the benefits of caching. In Azure, tools like Azure Cache for Redis provide mechanisms to monitor and manage the size of the cached data. Proper data sizing ensures that the cache remains efficient and cost-effective, balancing the trade-offs between memory usage and performance gains. Managing connections to the cache is another vital aspect. Each connection to the cache consumes resources, and too many connections can overwhelm the cache server, leading to performance issues. Azure Cache for Redis offers features like connection multiplexing, which allows multiple operations to be sent over a single connection, reducing the number of connections needed. Additionally, connection pooling can be used to reuse existing connections, further optimizing resource usage. Proper connection management ensures that the cache can handle high loads without becoming a bottleneck. Data encryption is essential for securing cached data. In Azure, data can be encrypted both at rest and in transit. Azure Cache for Redis supports SSL/TLS for encrypting data in transit, ensuring that data is protected as it moves between the application and the cache. For data at rest, Azure provides encryption mechanisms to protect the data stored in the cache. Implementing encryption helps protect sensitive information from unauthorized access and ensures compliance with security standards and regulations. Expiration policies determine how long data should remain in the cache before it is considered stale and removed. Setting appropriate expiration policies is crucial for maintaining cache efficiency and data relevance. Azure Cache for Redis allows you to set expiration times on a per-item basis, using techniques like time to live, TTL, and sliding expiration. These policies help ensure that the cache contains only fresh and relevant data, reducing the risk of serving outdated information and optimizing memory usage. Monitoring the performance of the cache is essential for identifying and addressing potential issues. Azure provides various tools and metrics for monitoring cache performance, such as cache hit ratio, memory usage, and latency. By regularly monitoring these metrics, you can gain insights into how well the cache is performing and identify areas for improvement. Tools like Azure Monitor and Application Insights can be used to set up alerts and dashboards, providing real-time visibility into cache performance and helping to ensure that the cache remains optimized. Despite best efforts, issues with caching can still arise. Common issues include cache misses, high latency, and memory leaks. Troubleshooting these issues involves analyzing cache performance metrics, reviewing application logs, and identifying patterns that may indicate underlying problems. Azure provides diagnostic tools and logging capabilities to help with this process. By systematically identifying and addressing the root causes of caching issues, you can ensure that the cache continues to provide the desired performance benefits. Optimizing the configuration of the cache involves fine-tuning various settings to achieve the best performance. This includes adjusting parameters like cache size, eviction policies, and connection limits. Azure Cache for Redis offers a range of configuration options that can be tailored to the specific needs of your application. By experimenting with different configurations and monitoring the results, you can identify the optimal settings that provide the best balance between performance, cost, and resource usage. As application demand grows, scaling the cache becomes necessary to maintain performance. Azure Cache for Redis supports both vertical and horizontal scaling. Vertical scaling involves increasing the size of the cache instance, while horizontal scaling involves adding more cache instances and distributing the load among them. Azure provides features like clustering and sharding to facilitate horizontal scaling. By implementing a scalable caching strategy, you can ensure that the cache can handle increasing loads without compromising performance. Advanced caching patterns can further enhance the performance and efficiency of the cache. Patterns like read through, write through, and write behind caching can be used to optimize how data is read from and written to the cache. Additionally, techniques like cache aside and distributed caching can be employed to improve cache utilization and reduce latency. By leveraging these advanced patterns, you can create a more robust and efficient caching strategy that meets the specific needs of your application. High availability is crucial for ensuring that the cache remains accessible even in the event of failures. Azure Cache for Redis offers features like replication and automatic failover to provide high availability. By replicating data across multiple nodes and automatically failing over to a replica in case of a failure, you can ensure that the cache remains available and reliable. Implementing high availability measures helps minimize downtime and ensures that the cache can continue to provide performance benefits even in adverse conditions. Implementing security best practices is essential for protecting the cache from threats. This includes using strong authentication and authorization mechanisms, encrypting data, and regularly updating and patching the cache software. Azure provides various security features and tools to help secure the cache, such as Azure Active Directory integration and network security groups. By following security best practices, you can protect the cache from unauthorized access and ensure that it remains a secure component of your application architecture. Managing the cost of the cache is an important consideration. Azure Cache for Redis offers various pricing tiers and options, allowing you to choose the configuration that best fits your budget and performance requirements. By monitoring usage and optimizing configuration, you can manage costs effectively. Additionally, features like auto-scaling can help control costs by automatically adjusting the cache size based on demand. Effective cost management ensures that you can leverage the benefits of caching without incurring unnecessary expenses. To illustrate the concepts discussed, let's look at a real-world case study. A leading e-commerce platform implemented Azure Cache for Redis to improve the performance of their application. By carefully sizing the data, managing connections, encrypting data, and setting appropriate expiration policies, they were able to significantly reduce response times and improve user experience. They also implemented monitoring and troubleshooting practices to ensure ongoing performance and addressed scaling and high availability to handle peak loads. This case study demonstrates the practical application of secure and optimized caching patterns in a real-world scenario. Implementing secure and optimized application cache patterns is crucial for enhancing the performance and scalability of Azure solutions. By carefully considering factors like data sizing, connections, encryption, and expiration, and by leveraging Azure's tools and features, you can create an efficient and secure caching strategy. The next steps involve applying these principles to your own applications, continuously monitoring and optimizing the cache, and staying updated with the latest best practices and advancements in caching technology. By doing so, you can ensure that your applications remain performant, scalable, and secure.